Our game is you clone the repo, then you open this file, you open source, you open main, you open Java, then you open .com example, and then you have Pacman game. You can also open entities to see the classes and grade that. So obviously we click Pacman game, then you click start, and this is how we start the game. So we get a brief moment here to kind of get ready, and we're off. Alright, so ghosts eat all the pellets before any of the ghosts eat us 3 times. You have a score in the top corner for eating pellets. Let's just take a break and actually notice how this red one here directly follows me, whereas this pink one tried to flank me because she moves 4 tiles ahead of me, just like the real Pacman game. They have different logics based on the color of the ghost, and they have a bit of a different personality. So like I was saying, I have 3 lives, now I have 2 lives because I just died. I can get higher score with the pellets, or I'm going to go and eat a power-up, and then I'm going to eat the ghosts to see what happens. So I got a power up, they're weak, they're slow, I'm going to eat the ghost. That ghost now runs to the center, and it will recover and then come back to try to eat me again. This is kind of the main loop, so you want to use these power up pellets wisely. And look at this one right there. That guy, what he does is he thinks about where Blinky is, and he kind of does the kind of reverse direction based on where Pacman is to kind of flank and close in on Pacman. So this one directly follows me. Look at the orange one, by the way. He directly chases me, but the moment I get close, he'll run to this little corner. That's kind of his logic. He's kind of weird. Look, he's just running to the corner whenever I'm close. And now I will play the game, and look, I died. So I died, and I have 2 options: either tap space and quit the game completely, or I'm just going to click enter and restart the game because I'm on a quitter. And we're off again. So I'm going to do a time lapse because this is going to be quite tedious. Watch me hopefully win the game first try. Sorry, buddy, but I'm going to win the game. I won! Congratulations, with 4,000 score and 3 lives remaining. Now let's try again. Oh wait, what's this? Is it just me? Or all the ghosts coming out faster? Oh my gosh, it must be because now it's harder. So they will keep coming out faster. Let me get this power up. Let's see how long it takes for them to recover. Oh, that was pretty fast. So they kind of recover a bit faster than usual. And so I need to be careful. And so this is how the main game works. Every time I eat them, I get this little bonus score as well. Oh, I just died because he recovered quite fast. My contribution is significant. What I did was the tick rate, the game board, the backend to GUI logic, Pacman's pending move inputs, the movement of the ghost, the smart pathing of the ghost, the kind of entire inheritance system, as well as encapsulation, the key inputs, and some of the game loop and collision effects. Basically all the ghost modes as well. So I handled most of the stuff. As you can see here, we have a whole diagram on what we did. This is kind of how the inheritance works. There's entities, and then it goes into ghosts and Pacman, and ghosts go into further specific ghosts and how they actually path to Pacman, because each of them are different. The main logic you need to know though is it's based off of a 2D char board as a backend, and this way we will just do all the logic on this at a per tick level. As then on the per tick level, you'll just take whatever this thing is. So this hashtag represents a wall, this represents a ghost, and we'll just throw it onto the GUI, and we'll think about things like what direction they're facing and whatnot, based on of their properties like their int yx directions and their char direction. I'll talk about the hardest things I've implemented. This is the main game loop you can see. The hardest thing I've implemented, because I don't have enough time to talk about everything, is probably the Pacman's tick movement as well as the ghosts. So his tick movement basically works on the pending movement system, where basically if you're moving and you don't put anything, it'll keep going the last direction that you did, the last move. And if you do move down but it's invalid, it'll save it and it'll continue going until it is valid, and then it'll finally make the move. So the real hardest part, and I felt a lot of challenge because I had to copy one-to-one the actual Pacman game logic on each of the ghosts, which I was quite successful and I'm happy, is this is kind of the logic of behind it. I stored all of these, the W, A, D, S, into kind of a hash map, but I'll explain kind of through this little bit video. So basically when a ghost moves to a position, it'll have multiple directions. This direction here is invalid because this direction here is invalid because it's the last direction he made. He can't turn around 180. It'll be too difficult for the player to understand where the ghost is going. So that's removed. And then this one over here on the bottom is a wall, so he can't make that movement. And now we're left with just two movements. And with how it targets is it'll find whatever path is closest to each other linearly, and then it'll make that move as its final move. To show that this is the case in our code base, I'll show you over here the last element of it. So obviously, you have a hash map with a character and an integer array, which is size 2. You can see here coordinates 0 and 1. And how this last element works to find the linearly distance is I take the remaining characters in the keys that have been removed previously. This is something called move filter. It removes these keys from our hash map. But the remaining ones, we take the target minus the coordinate, and then we take the y minus the y coordinate of the ghost, obviously, and then we kind of times those differences together and plus them together to get the linear distance, and we're iterating over the keys in the key in keys. And so when it is the lowest, then we'll set it to be now the new lowest that the next one has to beat, and we'll set best move to be that specific key. At the very end, we'll return the key. Inheritance works is we have entities, and then we have Pacman. And what are the things being inherited? Well, we've encapsulated in entities a int x and an int y and a char direction for both the ghosts and Pacman. Obviously, you can see we've used all of them and we're using them constantly. There's also other elements that are overridden, like the move, as well as the update position, which throws it onto the displays onto the back end grid, and there's other elements. Then on the ghost, there's another level of inheritance that's being done because a lot of the ghosts have similar qualities, like they both get eaten in Pacman when they're weak. They all have basically ghost states, ghost modes. They have an identifier, and then they have certain other elements like every other tick for it to make them slow down, free the ghost in the beginning. This is very specific to ghosts, but you can see that in this kind of system, we will also have the movement, and all of them have this kind of similar movement, how they will never hit a wall, how they'll never turn around completely, and how they act when they're frightened, how they act when they're eaten. They're all kind of similar. But then on another level, we'll have the specific target of where they are going. So, example, Blinky's right on Pacman, and we're using the get X and the get Y, right? That's how we did that. Or as Pinky is actually not just on Pacman, but we see that we've used actually right over here. We've used his direction because Inky goes 4 ahead of Pacman. So if it's W, we're going to move 4 up chars as the target, and we're going to path to it using the inherited ghost targeting system and pathing system. The morphism was over here. I could have made everything entities, but I prefer that Pacman says Pacman and ghosts say ghosts, so it's able to understand that these are all ghosts because they're just random names. You don't know what they are. So now we know they're all ghosts, Inky, Blinky, and Clyde, and that's why we made them over here. And of course, they all start at kind of the same position since they're all in the box. And so this is how I implemented object-oriented programming into my design. So I did not have to every single time change individual ghost logic for certain elements. All I had to do is change this, let's say, frightened state, and I change maybe the timer is now less or higher, and I will change it for all of the ghosts, saving me significant time and resources, and help utilize the tools of Java into my program.